Let us review the polynomial characteristics with the help of some multiple choice questions. The question here is, the possible number of turning points for a 7-degree polynomial are, we are given 4 choices. You can pause the video, select the right answer, and then look into my suggestion. So let's try to experiment it. Well, when we say 7-degree polynomial, we could think about x to the power of 7 is also a 7-degree polynomial, and this kind of will be like this. Now this polynomial, as you can see, doesn't turn. So the number of turning points in this particular case, we can write down that the number of turning point in this particular case is 0, right? Is none. It doesn't turn. Now, if I take a 7-degree polynomial, which is kind of x times x, let us say x minus 1 to the power of 6, for example. That means it has 2 zeros. So one is right there and the other one is, let us say, at 1. Okay. So in that case, what happens? Let me try to sketch this polynomial since the leading coefficient is positive, right? So we are just making approximate figure here. X end behavior is that it moves from quadrant 3 to quadrant 1. So what we have here is a polynomial which is kind of going like this, and then when it goes across this, then it has to turn from this point and go up. You see that since this is degree 6, even degree, so it cannot cross the line. So what you observe here is that the turning points are 1 and 1, 2. So it has number of turning points as 2. So what you notice here is that a 7-degree polynomial will either have 0 or 2. It cannot have 1 turning point. Do you see? Now if I add more zeros to this, that is to say that, now let me consider another function, and in this case let me say my function here is x. Okay, let me just make a general suggestion here. That is, we have a degree 7 polynomial. Let's say it goes up like this and it turns. Now since the end behavior dictates that we have to end in coordinate 1, that means we have to make one more turn so that we move in this direction, right? So we have to make a turn. It could be from anywhere. So what we get is 2 number of turns, as we concluded with this particular example. Now if you want to turn once again, then we have to turn again to reach in coordinate 1. That means every turn is in a set of 2. Do you see that? So the next number of terms could be 4. Do you get the point? And maximum number of turns which a 7-degree polynomial can have is 6. The reason is a polynomial with 7 degrees, right, could have 7 zeros, and every time to connect with another 0 it has to turn. So it has to turn 6 times, right? So these are the possible number of turning points which a haptic or 7-degree polynomial can have. So 0, 2, 4 and 6 is the right choice. So the option C is just correct. So remember one thing, that odd degree polynomials, so let me summarize here, as odd degree polynomials will have even number of turns. I hope that helps you to remember that odd degree polynomials will have even number of terms. If the question would have been for an even degree polynomial, you will notice that it will have odd number of terms, right? Another important thing which you know is that odd degree polynomial has minimum of 0 turns, and even degree polynomial has minimum of 1 turn, right? So that gives you all possible number of turning points for a polynomial, right? I hope that helps. I'm Anil Kumar. Subscribe to my videos and learn more in details about any topic in maths. Thank you and all the best.